Yeah, so my name is Nazar, I'm from Ping Network, and there are three main resources in every computer and server around the world. There is computation power, there is storage, and there is bandwidth. And first two are scaled super easily. You just go in the middle of nowhere and build a huge data center. You just pack it with hardware and this stuff. And bandwidth just doesn't work this way. So if you want to scale bandwidth, you actually need to be close to your end user. You need all of these points of presence around the world, and it costs fortune. And this is why there is a huge multi-billion dollars industry, which is bandwidth-heavy businesses like VPN providers, content delivery networks, and data scraping software which struggle to scale. And they work with traditional cloud providers that allow them only mediocre 30 countries coverage. The bravest of these guys try to scale their own networks around the gray areas, working directly with local providers, but eventually all of them give up because it's just enormous work in terms of operations. And the craziest thing is that in all these gray areas there is hardware which is being severely underutilized. There are data centers, there are offices, there are even households with idle resources. And this is crazy. So Ping solves this problem. We are building a decentralized networking layer which allows everyone to chip in their hardware. It can be institutional-grade hardware from data centers. It can be retail-oriented devices from individual contributors like you and me. All of this stuff is pulled into one huge platform that allows businesses to scale effectively. And by bringing decentralization to the table, this thing works like a charm. So first of all, we allow unmatched geo-coverage. So there are hundreds of countries down to the city level, and it also brings latency a couple of times down. So the network is just more efficient. The second important thing is resilience. So if tomorrow, for example, one of data centers gets flooded, our clients will not even notice it. So it's not a catastrophe and you are down for days. And if one of them decide to scrape the whole internet, maybe, like Google does, we'll be there to serve this bandwidth right amount right away. And the third one is that economies at the scale are always more cost effective. So we are on a closed DevNet right now. We are serving 80 terabytes of data daily for our first 5 B2B clients. And we already made a lot of partnerships with the supply and demand side both, ensuring that we'll be able to increase this number 100 times pretty soon. And talking about the plans, we will release public testnet this summer and scale the whole thing 100 times to be able to serve to hundreds of clients, terabytes, basically petabytes of data daily by the time we launch mainnet somewhere in the end of this year. And the end game for us would be just allow anyone to chip in their hardware and contribute it effortlessly to power the next generation of technology businesses. So to do so, our team is packed with engineers which were building content delivery networks for the most loaded sites in the world. And we are backed by the leaders of the industry that help us to ensure that everything is economically and technologically secure. And we'll be raising our seed round in April, so if anyone is interested to learn more about Ping, feel free to reach me out, we'll be happy to connect. The cherry on top is that we've built our own decentralized VPN application recently on top of our network that you can try out in test flight. And thank you. That's Ping.
Woo!
Very good presentation. You know, between Itaipu, the big dam, the second largest one in the world, and Sao Paulo, there's a huge demand, but there's a lot of latency. How do you think you can solve that problem? Because all the computing is needed in Sao Paulo, which is far from Itaipu, and for things like AI, you need like 200 milliseconds. So is there any way you can solve that?
Yeah, so we are not building physical infrastructure ourselves, so we will not be able to lay optic wires to solve this problem. But what we can do is power CDNs to make the whole internet more efficient. So for example, you watch YouTube, Mr. Beast's video, and it will be served not from somewhere of the other part of the world. It will be served from your neighbor maybe. And this will allow to less load this industrial huge network between countries and peering centers. So the whole internet should be more efficient in the end of the day, and we will be contributing to it with our technology.
Amazing. Any other questions? Jury? Okay, thank you, Nesser. That was some serious tech infra.